Yeah, so this is another one of those which one doesn't belong. You actually have already looked at this, but what we're looking at over the next 3 days, is symmetry. Okay? So, now if you have a which one doesn't belong for this and you want to share it, that's fine. But I also want you to think in terms of symmetry for these. So you can just answer the question generically first. So which one doesn't belong here?
Bottom right.
Bottom right because? It's not a quadrilateral. There you go. So there you go. So it's not a quadrilateral. It doesn't belong. What do you think?
It's also off-center.
It is also off-center. I don't know if we caught that one before because I think you have seen this already. But that is just a little bit off. So if you're OCD, that's going to drive you insane. Okay. Any of these other ones not belong for any particular reason?
Top right. It's like shaded.
Okay. Top right is shaded. What about top left? Does not have equal sides. Everything else has congruent sides. Top left does not. And then the bottom left is tilted. Okay, guys. All right, guys, let's stop the conversations. So the bottom left, when we say it's tilted, another way is there's no horizontal side anywhere in here. All right? Obviously, the top two do. The bottom one is sitting on a flat base, but this one is the only one that does not have any horizontal sides. Okay, so that's kind of a generic way of looking at it. Now, if you don't have an answer to this, that's okay. We're going to be talking about symmetry today. But from the perspective of symmetry, does anything look a little bit off? Or, I mean, are there any comments, any notes?
The top right is like kind of filled in.
Okay.
Like it looks filled in.
It is, yeah.
The bottom left looks like it's higher up.
Okay. So if you're looking at the entire box as a figure that you're searching for symmetry, then yeah, if it's off-center, what are you thinking, Audra? Okay, so the amount of sides, okay guys, the amount of sides on each shape will have an effect on the symmetry of it, but, so I mean, that's a good observation, and we'll talk about that a little more. Well, just a second. Yes.
They could like.
I thought you had an observation to share.
It could like all be cut in like different ways, but then the what's it called, pentagon can't be cut in like.
Okay. So yeah, we've got maybe differing types of symmetry. I don't know if that's exactly a way of summarizing the thoughts here. What were you going to?
Bottom left. Line on the bottom, like everyone does, have a lateral line, so the bottom left has a fringe.
Okay. So right now, I just want you guys thinking about this. I'm not expecting you to actually have perfect answers to this, but at the very least, you're thinking about symmetry now. And I want to show another picture. This one right here. When you look at this figure, just answer generally, does this look symmetric to you?
Yes. I mean, yeah, but like you, it's gross.
Yes, but you. All right, we got that.
Could be.
Okay, so what we're going to be talking about today is that we have different types of symmetry. And so if this one is seeming symmetric to you and you can't figure out why, we're going to talk about that. But let me first of all come around with your worksheet for today.
Looks like a Mario.
Okay, so the kind of symmetry that we were talking about before, and the kind of symmetry that you guys are very familiar with, is line symmetry. All right, so line symmetry is pretty straightforward. It is basically a line of reflection. So if I draw a line of symmetry to this isosceles triangle right here, then it's going to be a line of reflection, meaning that when I reflect a point, all right, so when I reflect this point right here, I'm drawing it kind of with a blue color. When I reflect that point to the other side, it's going to land on its corresponding side on the other. And we've been working with reflections, so this is not anything new. But you can also see why we're talking about symmetry here, because it does deal with transformations. Okay. So this is kind of the main takeaway. I'm going to go ahead and highlight this real quick. I know you guys probably don't have highlighters, so you can just put a box around this or something. But line symmetry is one type of symmetry that you need to know about.
There's already a line with it.
Well, yeah, but I'm saying like highlight it in some particular way. Put a star next to it.
Okay.
Wait.
Well, you know what? It's your notes. You do whatever's going to make it stand out for you. All right. Now, here's the main takeaway also. Down at the bottom, it says another way of thinking about line symmetry is that a figure has line symmetry if there exists a line such that the image of the figure when reflected over the line is itself. That's a really wordy way of saying this. A line of symmetry is a line of reflection. All right. So pretty simple concept, just, stating it like that. A line of symmetry is a line of reflection. I will go ahead and say, as simple as this might be, just explaining it, it is, on the test, historically it's been where people miss a lot of points because they don't look at the figures carefully enough, and they'll find maybe one line of symmetry, 2 or 3, or actually find lines of symmetry where there aren't any. So you really need to take the time to look at the lines of symmetry carefully. Make sure you found the correct amount. All right, you're going to have some guideposts along the way to help you. So I'm going to go ahead and point out real quick that, well, not point out anything, but what I want you to do is look at these 4 shapes right here. And I want you to figure out with your patty paper, if it's helpful. You're going to use your patty paper for sure later. So you might as well try it now. See if you can find any lines of reflection running through this where this figure will reflect onto itself. So you're going to have to flip your patty paper over in order to get this to reflect, for all 4 of these. So try and find the correct number of lines of symmetry, and you just write it up above the figure. So this first one right here, this triangle, how many lines of symmetry were you able to find with that? None.
Well, what about if itself as a whole? What about if the middle is like the line of symmetry just to the other side and find it?
All right, and we can look at that real quick. I'll just draw it up here what's going to happen. There are no lines of symmetry. I'm going to go ahead and show that. If you thought there's a line of symmetry right here, all right, what's going to end up happening is that you're going to end up with a triangle that looks like this. I'm going to draw it in red real quick. All right, reflecting over is going to give you that. So it's close, but it's not a line of symmetry. It does not map onto itself perfectly.
That's a great picture.
Thank you. Okay, so it turns out we have no lines of symmetry there. What about the next one? 2?
No, wait. 1, 2.
Oh, yeah, true.
Okay, I'm hearing 2 very confidently.
No, wait, yeah, no, that kid's right.
Okay, so we're finding some agreement here. I'm going to write 2 down real quick.
Nah, 4.
Okay, so let me guess real quick. All right, you have a line of symmetry right there. Everyone find that one? All right, you have a line of symmetry right here. Everyone find that one? Okay. All right, make sure your eyes are up here.
There's 2 more.
Okay, Brandon, make sure your eyes are up here. Okay. So, if you thought there were more, you probably were looking at the diagonals. And let's see what happens here. I'm going to get rid of these two lines that I drew. So if I try and reflect over that, this is what it's going to look like. Oh, that one's an actual line that I have.
That was nice. That was for David.
Oops.
It was two. It was two. I was wrong. Well, the kid was wrong.
All right, so I screwed up that rectangle a little bit, but it's going to look something like that when you reflect over that line. Just work with it. All right, I was trying to visualize that best I could.
Do you have like a straight line tool thingy? Why don't you just use that for everything?
Well, it doesn't work as well. Okay, so there's only 2 lines of symmetry there. Next one, how many lines of symmetry do we have for the hexagon?
3.
Okay, so where did you find your 3? Okay, are there any others? Hey guys, let's stop all the side conversations. Where else do we have lines of symmetry? Sky. Okay, we also have one right here.
Oh my god, there's 4.
Oh, well, are there 4? There's 6.
There's 6.
Oh, yeah.
Holy cow.
All right, so I just drew 6 lines on there. And yeah, we've got the 6 right there.
That's so cool.
Okay, now this is one that's, it can be a little bit confusing at the end, especially as you're looking at this. So if you're trying to count the number of lines, let's say you're just drawing them on there. You got 1, 2, 3, 4, 5, and 6. If I keep going around to the next one, that's one I already counted right here for number 1. So there's 6 of them on there. Okay, I'm going to erase all that. All right, and the last one. How many lines of symmetry were you able to find? I see 0. I see, and I've heard 2. Okay, so did you guys think this is a line of symmetry?
Yes.
Okay, if I reflect over that, it's going to look like this.
Not a lot. You're tripping.
Okay, well, I can go back to the paper. We can look at that. All right, so I hope we all agree there's no lines of symmetry. But this leads us to our next topic, or to our next type of symmetry, because we look at this. What is this shape, first of all?
That is in...
That's a parallelogram.
That's a parallelogram. We look at this parallelogram, and I think we're all pretty certain there's some kind of symmetry going on. So what is happening if there's symmetry, but it's not line symmetry? We have different types, and that's what we also had with this shape right here. We have symmetry in that, but it's not line symmetry. We have what's called rotational symmetry. So the basic idea is that I can rotate this figure around the middle and get this to map onto itself. And that's why we can see the symmetry. Our eyes and our brains are processing it as symmetry, even though it's not anything where there's a reflection involved. So let's look at this one real quick. I know it's already underlined, but we're going to look at this right here, and we're going to point out rotational symmetry of a figure. Okay, and it's really straightforward. I don't need to add anything to this, but this is one of the main types of symmetry that you need to look for. And we'll go back to the same figures as before. We were focused on that parallelogram, and I'm just going to do this on the screen. But if we look at that parallelogram, I'm going to label this real quick as A, and then I'll just, okay, A, B, C, and D. We'll do this on paper in just a second. But if I rotate this around, if I start rotating this around, then this A eventually will map around and land on the C. Okay? And then I can keep rotating, and the C will map onto the A again. So how many rotational symmetries do you think we have here? 2. Okay, and we'll show that on the paper in just a second, like I said. But right here we can say we have 2 rotational symmetries. So down underneath, I want you to write down the number of rotational symmetries that you have. So try that. Okay, so let's just start with this one right here. How many rotational symmetries were you able to find?
0.
We're looking at the very first triangle here. 1. So, and this is something I didn't say very clearly before, but rotating a full 360 degrees counts as a rotational symmetry. So now the next question is there any figure that will have 0 rotational symmetries? No, it's always going to map onto itself after 360 degrees. We'll talk about that in a minute. But yeah, this one has only 1 rotational symmetry. What about that rectangle?
2.
It has 2. Yeah, 2 rotational symmetries. So if I took this and started rotating it around, this point's going to rotate around and land on that one. So that's going to be 1. And then rotate around even further and land on that again, which will make 2. And what about the hexagon? How many did you find? 6. Okay, so again, this point right here is going to map onto every single point going around. So 1, 2, 3, 4, 5, and then back to where it started makes 6, 360 degrees. All right, so this is, well, actually, I'm jumping ahead a little bit, but we're looking at these numbers. We've got all of our line symmetry right here, all of our rotational symmetry down below. Look at those numbers, and does anything jump out at you?
Almost, actually.
Yeah. 1 where? For which shape though? This one right here has 2 because again, A can rotate around and land on C. Yeah, and so this is where the patty paper, rotating that around is really going to be helpful. All right, so we've got 0, 2, 6, and 0, and then 1, 2, 6, and 2. So think about this. Which of these figures have line symmetry? So which of these have line symmetry? Yeah, just the rectangle and the hexagon. Now, the 2 that have line symmetry, how much rotational symmetry do they have? The same amount. This is not an accident. This is not a fluke. You will always, okay, I should say it, be careful how I say this, make sure you're paying attention. If you have line symmetry, you will have the same amount of rotational symmetry. It doesn't matter if it's 1, 2, 3, a million. If you have any number of line symmetry, you will always have the same amount of rotational symmetry.
Why?
Now, it does not work the other way. You can have rotational symmetry and no line symmetry. And we see that with the 2 on the outside. So this first one has 1 rotational symmetry and no line symmetry. This one has 2 rotational symmetries and no line symmetry. So it does not go the other direction. But if you have line symmetry, you will have the same amount of rotational. So in fact, we're going to write that down. All right, at the bottom of the page, go ahead and copy this down as I'm writing it. So if you have line symmetry,
What's that random line?
I don't know.
That's gonna piss me off.
So if you have line symmetry, and I'm going to make sure it's very clear that we're talking about line symmetry, then you will always have the same amount of rotational symmetry. You'll always have the same amount of rotational symmetry. And I'm going to really emphasize that same amount. Okay, and we're going to add another little note here that says, I'm going to phrase it differently, sorry. You can have rotational symmetry and have no line symmetry. All right, so this is just showing that the inverse does not also hold true. So line symmetry will equal rotational symmetry if you have line symmetry. But it doesn't go the other direction. You can have rotational symmetry and no line symmetry at all. Very, very important concept.
So it's like an input-output thing if you think of it in a way.
Yeah, it's kind of like the one-to-one versus, yeah. Okay. All right. The last note, and we don't necessarily have to write this down, but we might. That hexagon right there is a regular hexagon. And that means, we already talked about regular, that means that all the lines are the same length, all the interior angles are the same angle. And so the main point with that is that you will never have more line symmetry or rotational symmetry than the number of sides. So this has the maximum amount of symmetry that a hexagon can have. It has 6 lines of symmetry, 6 rotational symmetry, and it cannot have more than that. A hexagon cannot. So notice that that rectangle is not a regular polygon. The sides are different lengths. It only has 2 lines of symmetry. But a quadrilateral can never have more than 4. So that's going to be kind of a helpful guide. If you know you have 7 sides to your figure, the maximum you're going to have is 7 lines of symmetry. Okay? And so I'll add a note to that. So, if I can spell right, you cannot have more lines of symmetry than the number of sides. You cannot have more lines of symmetry, and that also goes for rotational. You cannot have more rotational symmetry than the number of sides. Okay, now these are good general rules to keep in mind because, I mentioned this before, this is the topic where a lot of people make a lot of mistakes and lose a lot of points in their test because it seems so simple and yet they don't take the time to look at the figure carefully enough. All right. So we have one other type of symmetry to talk about. Has everyone copied everything down?
Yep.
All right. Otherwise, you can talk with the people you're sitting with. All right. The only other type of symmetry that we need to worry about is something called identity symmetry. Identity. So that is at the bottom right of your page. This is kind of I don't know what you'll think of this idea. But identity symmetry is basically when you rotate a figure 360 degrees, it's going to land right back where it started. And it's going to be the same figure that you started with. No, every figure has identity symmetry. No matter how it's arranged, when you rotate it 360 degrees, it will always map back onto itself. Okay, so this is your identity symmetry, and it's just a type of symmetry that you need to be aware of. You just need to be able to state that every figure has identity symmetry. It is a type of rotational symmetry, and we count it as a rotational symmetry. So that first triangle, we said it had 0 lines but 1 rotational symmetry. That 1 rotational symmetry it had was the identity symmetry. All right, and this comes from in math, we have a lot of identities. So one of the identities that we have is in algebra, you might have seen this before, a plus 0 equals a. Why do we need to have that rule? Well, it kind of sets the foundations of math. It's not something we dwell on, but it's an important rule that we have. So that's called the identity property of addition. A times 1 equals a. That's the identity property of multiplication. It's basic ideas that we build math off of, but for our purposes, it doesn't really matter a whole lot. It's a very basic idea that rotating 360 degrees gives you the exact same figure. Okay, so you need to just be aware that that's a symmetry that we have. So if we look at the next page, and we'll just do the first part of this in class today. Go ahead, cross out all of question 3. Yeah, and that's a lot that we're not going to answer any of those questions, okay? So with this, you're looking at a square. You need to identify the types of symmetry, draw the lines of symmetry, identify the amount of rotational line symmetry that there are. I'll let you guys do that. We'll just do this first part together. 2a. What kinds of symmetry do you think this square has? All of them. So what are the types?
Line, symmetry, and rotational symmetry.
Line, rotational, and what else? Identity. So my question is, every figure is going to have what kinds of symmetry? No, you can easily have a figure without any line symmetry.
Rotational.
So everything's going to have rotational and identity, which is basically the same thing. Okay? So identity is not a major thing on your test. I'll probably ask questions, what type of symmetry do we have? And that's where you can show the identity symmetry. So line and rotational is the big thing. So go ahead, answer these questions here, and we'll go over that here in just a few minutes. So I'm going to give you guys some way more complex figures tomorrow. And so we're just looking at very basic stuff today. But you can look at figures that really start to confuse you, and you're having to look at it very closely to figure it out. But up here, how many lines of symmetry were you able to find? Okay, so we have 4. I'm going to go ahead and draw those in real quick. Hopefully you found all 4 of these. There's 1, 2, 3, and 4 right there. So this is where you can kind of save yourself a little bit of time and effort. I mean, just a very little amount. But if you have 4 lines of symmetry and you're confident in that, how many rotational symmetries do you have? 4. Remember, if you have line symmetry, you're going to have the same amount of rotational symmetry. So look for line symmetry first. If you find it, great. Write down the same number for for rotational symmetry and move on. If you don't find it, then you need to check for if there's any rotational symmetry. All right. And remember that you can never have more line symmetry than there are sides in the polygon. So this is a square. It's a regular quadrilateral, which means it's going to have the maximum amount of symmetry that you can have. So this one has 4. Okay, we'll continue looking at this more tomorrow and get some more practice with all kinds of different shapes.